Hello and welcome to Agile TD Mondays, today with Bart Knaack and his talk about unit testing as a team. As always, before Bart starts, I would like to tell you to register for the Agile Testing Days 2017. Head over to agiletestingdays.com and check out the program and register. And now to you, Bart.
Okay, hello everybody, good afternoon. This is part of the webinar that's organized by Trenick, formerly known as the DSC Hilterscheid, and I'm very pleased that you get the opportunity to actually give a presentation today. One of the topics that's very close to heart to me is testing. Of course, Agile Testing Days, it kind of reveals testing a bit in there as well. However, if you look at testing in the Agile environment, we see some, well, interesting things. So let me start with giving you all the time to get a pen and paper, because somewhere down this presentation, there'll be a challenge for you to actually do a exercise. So if you can all get to your pen and papers, then we'll start in 30 seconds. So everybody gets 30 seconds to get a pen and paper. Okay, how am I going to fill this in just 30 seconds? No, let's not sing a song. Good, I guess everybody has their pen and paper now, and if not, you'll just have to do it with your imaginary pen and imaginary paper. So let's start the presentation. Everybody, if they talk about Agile and testing, is talking about exploratory testing, because Agile is not structured. We do not want to have all kinds of pre-written scripts. We have the entire discussions about checking and testing. And well, actually, scripted testing is considered to be waterfall, and test design techniques, well, who needs them anyway? So let's all do exploratory testing. Well, I can tell you, if exploratory testing is the only testing that you're going to do, that you're going to end up with a lot of errors in production. So we need some kind of mechanism to tackle that. What would that be? I think the title of my presentation gives it away a bit. What we see is that a lot of testing at this moment is in an ice cone form. So we have the ice cream cone, which means that we have little unit testing, a lot of some service component testing, and a lot of end-to-end testing. And actually, end-to-end testing, that's where the exploratory testing comes in, because you want to have the full flow, you want to see the entire system, you want to have a working system to be able to check in exploratory way whether it's working right or not. So if we want to decrease the testing done at an end-to-end test level, actually in exploratory testing, we need to do testing at a different level. For instance, 70% of all test cases can be dealt with at the unit test level. A lot of tests that we are now doing end-to-end, like checking the validation of a telephone number, or checking whether names can be dealt with in diacritics, the strange signs that you get, like the accent aigu and stuff like that. That's all can be done at unit test level. And that means that we can not only do them at unit test level, but if we do them at unit test level, we can make them more efficient, and we get earlier feedback, and feedback is everything that we want in Agile. So earlier feedback, more efficient, quicker testing, unit testing is the way to go. However, unit testing is not understood very well by all people. So how can we, if everybody in the Agile team is responsible for quality, get people to do proper unit testing? Let's wait and see. One of the first things that we see in Agile and in CI/CD, and for people who do not know CI/CD, it means continuous integration and continuous development, is that everybody is responsible for all tasks at any time. So quality, having quality in your system also is a responsibility of everyone, and not just of a tester or a quality engineer. So we actually want to have the entire team to be helping out in getting quality in. And this also means that unit testing, or testing in general, is a task to be done by everybody. What we see is that if we have, for instance, a test strategy where we have a one-pager where we write down all the test cases or all the things that we need to test, all the risks on one page, then during the refinement and planning sessions, we need to think about what does it mean to actually also test this, well, user story or whatever we are going to refine, such that we also take in the time for testing in our sprints for each of the user stories. That doesn't also mean that we were going to arrange time to do this. And that means that we actually get the time to test properly. So if you want to do proper testing in a sprint, make sure you take them into refinement as soon as you do, well, actually, as soon as you want to capacity check the number of hours or user stories that you need to have in your sprint. Interesting. And of course, we are all looking for T-shaped professionals. So what do we mean with T-shaped professionals? Well, we need people that are expert in one area, but actually also know a bit about the other areas. So developers should also know something about testing and possibly requirements engineering. Testers, on the other hand, might also be involved in development. Now, not all testers are really good developers. So what can we do about that? Well, one thing is that we want developers to think more about test levels and testing techniques. And we also want them to realize that testing is not just about the happy flows, because that's how developers normally test. They test whether actually the functionality that they have programmed is working fine, but not if it also takes out undesired behavior. And the test experts then need to be able to program. However, if you're not really proficient at programming, then you might end up with a lot of errors in production. So this is where unit testing comes in as a really interesting exercise to sharpen your programming skills, because the unit tests never go to production. They're only used to test the code that is going into production. So if you make errors in writing your unit test cases, the worst thing that can happen is that you do not test properly enough, but you do not introduce any errors into production. So think about that when you want to sharpen your programming skills. Unit tests might actually be a nice way of doing so. And last but not least, we really believe that pair programming can help you in setting up proper test cases, but also is a very good principle to set up quality in general. If there's more than one person looking at the same exercise at the same time, the chances of it going wrong are smaller. Pair programming can very well be done with the combination of a tester and a developer, or a tester and a business analyst, or a business analyst and a developer. So sharpen your skills, become T-shaped. Unit testing can help in that. So let's have a quick look at the definition of unit testing. Unit testing is where we want to have the smallest possible unit of code to be tested by itself, on itself, without using other functions, without using other protocols. So it's a small test. They can be repeated very easily, and they're done in a development environment and not actually in a testing environment. We add pieces of code to the code to actually test whether the real pieces of code that go into production are correct. So why do we want to test unit tests again? Well, first of all, if we are only going to rely on exploratory testing, it's not going to work. And second of all, we get much easier feedback much earlier and more efficient than in testing via the interfaces. So what do we want to unit test? We want to unit test all the things, everything. But haven't we said before that testing everything is impossible? Yes, it is. So we still have to think carefully on how to set up a unit test. Well, to give some examples of what unit tests are and what unit tests are not. Unit tests are runnable on a local workstation. So the developer that actually is developing code can run the unit tests on his own machine, repeatable times, very fast and independent of each other. So if I have two pieces of code, I can unit test them separately and then test the unit interactions later on at a higher level. What actually is not a unit test is, for instance, a test that talks to a real database, because we don't want to have the real database, because we don't have the real database on our local system. So we might have a spoof database or a mockup, but the real database is not used in unit testing. A unit test is not a unit test if it communicates across a network. Same analogy, we don't want to be dependent on anything else. We just have our own machine and want to test on that. And if it touches a real file system, it also is not a unit test. Of course, it can touch test files, and actually it should touch test files, but those are separate files that are on our own machine. and you do not have to do anything special in your environment to run it. So anything that requires an environment, anything that requires other systems to work is not a unit test. The unit test is isolated and on your machine. So let's think about an exercise. That's where you need your pen and paper. We are going to test a calculator. And the calculator is a function which just takes in operands and an operator and then calculates the result. So we do not know any details yet. This is very agile, to actually have your test cases ready before you start developing. It's called test-driven development, as some people might know. So let's give you 2 minutes to actually think about how you would unit test this calculator. So I'm going to start a timer, give you 2 minutes, and I'll be back in 2 minutes.
But are there several options to solve this task, or is there one correct answer?
No, there's multiple answers. So you can have multiple ways of testing this. So think about test cases, what you would do to actually unit test this calculator. Could be function calls to the function, small hint. I have to do something while you're doing it. Those were your 2 minutes. Good. I hope you enjoyed yourselves. I did. So let's think about how are we going to do for unit testing? So I have written down some questions for you. Have you thought about the following things? Have you thought about checking the parameter types? For instance, if you would put in words instead of figures. What if you would go to do something which delivers a non-integer result? Did you see on the previous slide that actually the function takes in 2 integers and delivers an integer? This sounds like a strange calculator to me. So by writing down the test cases, by thinking about the test cases, I might already have found the first bug that actually this, well, signature of the function that I get is kind of strange. So, I have to go down. Did you check for known baddies, like I said, division by 0? There should be something that is preventing this from ruining our code. There might also be strange operators, like an operator strange. Do you know what operators that actually are present in the code? No, you don't, because I didn't give you enough information. Did you check all the operators? Well, you don't know, because you don't know what all the operators are. Did some of you check for negative values or for too long fields? Maybe an integer only takes 128 bytes. Did anyone try to put in a double? And for non-binary operators, like if you just want to negate something, you don't get 2 operands, you only need 1. So you see that there's a lot of stuff in here that is actually unsure. And why is that? Because we do not know the contract. What we do not know is what actually this function should do. So I've given you an assignment, which is impossible. However, it already, I hope, started to make you think about, okay, what do I really want to do in unit testing? And there's a lot of stuff that you can do in unit testing. These simple calculator, there can easily be 20 to 30 unit tests checking whether the calculator is right. Anything I leave out in unit testing here can produce an error in production later. So what do we see with contracts? Well, a contract actually, and there's contract validation tests as well, is something that describes what a function should do. So if we have two units working together, then we see that the interaction between these units are an interface described in a contract. If we can check both sides of this contract independently, we save loads of time. We actually can have, well, some contracts which, if you have two functions which both have about 20 possible test cases, then if you would combine them, those two, that would be 400 test cases. But by making sure that I already check a lot of these test cases before I actually join these functions, I might end up with 50 test cases instead of 400, which is a big time saver. For instance, if we have a contract that states that we should pass an integer, then we should always test that we always pass an integer, or at least check if that's correct. So to be totally aware of a unit and to know how to test it, we probably want to have its contract or its interface description to make sure that we actually test the right things. And if we want to do the tests right, we want to do them from both sides. So for instance, if we have two functions, function A and function B, function A displays a table given its name, and function B gives the number of elements in the table. Function A will use function B to determine how many rows it needs to display. So if you have a contract that says how function A should behave and how function B should behave, then we also know what type of unit tests we want to do for side A and what type of unit tests we want to do for side B. I previously said that functions should be testable independently. And now we have a function A which uses function B. So how can I test a function A independent of function B? Well, we could do that by making a mock. And a mock is just a piece of code which acts like it's function B, but can only give back the predefined answers that we've given. So if we have a predefined answer for the mock, then we also know what the functionality is that function B does, and we can test function A independently of function B by using the mock. If then function B is actually programmed, we can actually put in function B and do an integration test to see that actually both things are working together properly. So contract validation tests are the first part of an integration test. If you first do the contract validation, you can later on do the integration test. So there are a number of language constructs that people can use to do unit testing. For instance, asserts. And in Java, you also have the throws and the try-catch. These are all kinds of language constructs you need to learn about as a tester to be able to do proper unit testing. So that means that as a tester, you might want to learn bits and pieces of the programming language that you're going to test. And how do you learn this? Well, ask the developers. A developer will tell you in a minute what an assert is, and then you will be able to use them to do your unit testing. That also means that as soon as you start talking to the developer, that for him to explain the language constructs to you, he will be interested in saying, well, what are you going to use this for? And you will say, well, I'm going to use it to set up proper unit tests. So if we look at something like the real deal, this is actually some real unit test cases of a calculator that I've put in earlier. And you see that instead of using the words, I've already used operands in a, well, the kind of the normal way that you look at them. And we see that I have some asserts in here. So for instance, the first test is test calculator 2, and it asserts that if I have a calculator that do a 1 and a 3 with a multiply operand, that actually the result is 3, and this test will then pass. So if you look at this 6 tests that I've put in here, they're all very similar. They all use the assert statement to just see whether I get the expected value back if I put in some operands into my function. So this is not scary. Everybody can do this. Now, let's go into some of the misconceptions that we see about unit testing. And the first misconception is that integration testing will catch the bugs anyway. That will only be true if I do really extensive integration testing. And like I said before, if you have two functions with 20 test cases each, the integration test of the entire thing will be 400 test cases instead of 40 if I do it properly in unit test. The next thing, of course, is the programmer's dilemma. Programmers do not make mistakes. Programmers are infallible. So why should they do unit testing? Their cases are right from the start. Well, this, of course, if it were true, it would be good news, because that would mean we would never have any problems in production. However, history has shown that this is not always true. So programmers do make mistakes, and we do have to check them. And unit testing, if you do it properly, can also help in refactoring your code. This means that if you refactor your code and your test and your functionality stays the same, that your unit tests can be used to check the refactoring. And last but not least, it consumes too much time. Well, the earlier you test, the less time it's going to take, the more efficient it will be, and the easier it will be to actually check for the defaults and to check for the bugs that you need to solve. So in that sense, all of these three misconceptions are real misconceptions. You really don't want to fall for them. So let's see some principles. Unit test, again, should be fast. You can actually run 1,000 tests within a second because they're part of the code. They should be isolated, so they should be independent from code and other unit tests. They should be repeatable, so you can rerun them at the same time and rerun them over and over again. So in case of refactoring, you can also use them to check whether your results are still valid. They should be self-validating. They should not be, depend on you looking at them to determine whether it's a pass or a fail. The pass or the fail should be part of the unit test, like we did with the asserts. They should be timely. And like I said, you can even write them before you write a piece of code. So this means that you can have your unit tests, write your code, run the unit tests, and decide whether the unit is good enough or not. But this also means that your unit test should cover all the possible behavior that your code might have. Interesting. And last but not least, they should be you cannot commit your code until all tests have passed. If you allow people to actually commit code that is not properly unit tested, then it will be a problem. And last but not least, they should be refactored along with your code. If you have refactored code, then you also need to refactor your unit tests. Good. How to isolate your unit tests again? Well, we can have mocks, which are pieces of code which behave just like the class that you're calling from your tested class, and then you can use them instead of a real function. And there's also stubs and spies. And I'm not going to explain them in detail, but if you want to know more about them, talk to the developers in your team. They will know what to do and how to set them up. So what would be the test techniques for unit testing? Well, they're the good old-fashioned techniques we already know. Input domain testing, boundary value analysis, equivalence partitioning, syntax checking. These are all things you can do at the unit test level. What techniques can we use more? Well, we could use fault seeding, mutation testing, and historical test data to actually ensure that the tests that we have are proper enough. If we have a unit test suite which will not trigger a fault being seeded, then it's not a proper unit test. You should add more test cases in order to do that. So, of course, we can also use coverage-based techniques, because at this moment we can still look into the code and see whether we have covered all the paths and all the branches. I think a lot of your testers will already know these techniques, but let's go through them very quickly. So for instance, if we want to have branch coverage, we can see that if we have a number of branches through our code, then all the possible branches of your code should be covered and all your nodes should be covered. So for instance, if we have a function like this, and we know that the function is depending on two variables, you see underneath 3 test cases that will trigger each of the paths through the code. So using the structure of your code to set up your unit tests is good practice. You at least know that you've covered all the bases but it might not be enough. You might have to think about the possible, well, tests like are the parameters used in a proper way. So equivalence partitioning, everybody will know this. It's a black box technique, so you can use it even when the code is not visible for the tester. But since it is visible now, you can also take in the information from the code to set up your equivalence classes. So if you have an equivalence class and we say, well, we have a number of partitions, some are good and some are bad, then we know which numbers to use. So in this case, there's a partition between 1 and 10, which is a valid case, and all the others are invalid. So we know that we can take at least part of the partition of before 0. We can take at least one test case between 1 and 10 and take some test cases out of the third partition. Why do we use this? Because we do not want to test with all possible values, because that actually is way too expensive. So by having an equivalence partitioning, we can reduce the number of test cases. So I want to see a show of hands who doesn't know about boundary value analysis. Oh my God, I cannot see you. Boundary value analysis is kind of like equivalence partitioning, unless with the exemption that you actually use the boundaries of your tests to actually set up more test cases surrounding these boundaries to make sure that you have proper testing in there. So let's look at a user story, because that's what we start off in a sprint. As an auditor, I want to follow the regulatory limitations on extending loans to customers. So we have a solution that is to build a function verify loan. Then, of course, we have to think about what are the legal regulations that we want to check. If you look at the requirements, we see that no loans should be issued to people below 18. And for bigger loans, we need to have a check that there's no bad credit. Can you spot the unit test opportunities in this? I guess you can by now, because these are just the normal testing things that we have in the traditional testing techniques with boundary value analysis and equivalence partitioning. The only change now is that we do not test them at the test level, we already test them at development level in the unit test. And this is where testing and development can meet up. We as testers know the testing techniques. We know how to set up tests in a proper way. We know how to actually bring down the number of test cases by using the proper testing techniques. Developers have the development skills that they can help us to set up the proper unit tests. And if we just want to wrap it up, unit testing can be an ultimate way of getting into the T-shape. So this means that if you know how to test, if you know what to test, and if you have the programming skills, then the entire team can work together to get the unit testing going. And the unit testing, like I said, should cover about 70% of all test cases, which means that at the unit level, you want to have a lot of tests. And like I said, the coherence between units can be done by contract validation tests. If you want to make the test independent, we can use stubs, mocks, and spies. And we actually can do testing techniques based from functional, error-based, or coverage-based. The constructs that we need to set up these tests can be learned, and can be learned quite easily by listening to developers and asking them what to do. And as we saw at the last slide, unit testing can start as soon as we have the user story selected for implementation. We do not have to wait for it to be finished. Actually, in test-driven development, we start writing the test cases as soon as we know that what stories have been selected for implementation. And that, my friends, is how we as a team can do unit testing. And I really would like to urge you to sit next to your favorite developer and to start unit testing together. Thank you very much for your attention, and I hope to see you at the Agile Testing Days 2017 in Potsdam.
Next Monday, Vicky Manewska will share her learnings from implementing Gherkin language and writing automation tests. And don't forget to tune in on Monday. Thank you very much, Bart.
You're welcome.
And thank you very much for taking your time and for your nice 2 minutes break. I enjoyed it very much. It was a pleasure.
Well, it's always hard to do a webinar because you don't have an audience, and I've prepared this 3 times and you still make mistakes because you do not get any feedback from the room, but okay.
But it was very fun. Thank you very much.
Okay. Well, hope to see you in November.